Okay guys, here's the video I promised you on the class opener. What we need to do first is to decide whether this function right here is going to be an odd or even degree function. Now because the end behavior is both going down, you know it's an even degree function. Or if they're both going up, it's an even degree function. But if they're ever going in different directions, like this end behavior down here is going up and this one's going down, so that's an odd degree function. We probably want to review this a little bit more. And in order to do that, let's take a look at these notes right here. A quadratic function, we already know a quadratic is a parabola, okay? And if the a value is positive, it's going to open up. If the a value is negative, your quadratic, your parabola is going to open down. Now here's the fact. Any even degree function will have the same end behavior as a quadratic. So you have anything to the power of 4, fourth degree, sixth degree, eighth degree, the end behavior is either going to be up here, or down here and down here, okay? Any odd degree function is going to have the end behavior of the simplest odd degree function, which is a cubic function. So here's your cubic function when your a value is positive, okay? The end behavior is down here and up here. And if you had a negative a value, then it would get reflected and it would be like this. So the end behavior would be up here and down here if your a value was negative. Please feel free to hit pause and rewind and listen to these explanations again. I'm going to go through this kind of quick. Anyhow, let's go back to this. And so we know that the function is even because they're both opening down. It says the leading coefficient positive or negative. Well, the leading coefficient is the a value. So we know that the a value is negative because it's both opening down. By the way, on the test, you're going to have to circle these on your answer column. And now let's write the f of x function. In order for us to write the f of x function, we first need to state all the answers of these guys. So let's state the answers right here to the side. What kind of answers do we have? Well, we have x equals negative 4. We also have x equals negative 2, and we also have x equals positive 2. So those are our three answers. Of course, they have different multiplicities, but the question is, how do we end up with the factored form of these answers? Well, where did these answers come from? This first answer came from x plus 4 equals 0. Okay, now if you think about that, how did I do that? Well, I could just add 4 here, it'll cancel it out, add 4 over here, and you end up with the x plus 4 that you see right there. Okay, so the idea is to get it equal to 0. So plus 2 right here, plus 2 over here, it's going to give you your answer x plus 2 in factored form, and that must be equal to 0 in order for you to solve it and get the x equals negative 2. And the other one, you'd have to subtract 2 here and subtract 2 over here. So you'd end up with x minus 2 equals 0, and the x minus 2 is in parentheses. So what is the factored form of this blue equation? It would, and magically there it is, the factored form. However, we still need to represent the actual answers. Like this answer right here, what kind of multiplicity is that x-intercept? Well, because it touches, it doesn't actually go through, it just touches, we know that it's the multiplicity 2. Okay, let's actually review multiplicity. So multiplicity 1, if you're looking at the graph from left to right, multiplicity 1, what does that mean? From left to right, that means that it would just cross right through it. Why? Because that's a line, and lines, when you think about the function of a line, it has the highest power of 1, that's it. Multiplicity 2 from left to right, let's say we're starting down here, and it's going up, it's just going to touch, and then it's going to come back down, okay? So it's like a little mini parabola opening down, or a mini parabola opening up, but the bottom line is the multiplicity 2 produces a little parabola, because the simplest type of function with the power of 2 is a parabola. So the multiplicity 2 produces a parabola from left to right. Multiplicity 3, from left to right, if I were to look at this, it's going to go, and is it going to cross? Yes, it is, but it's going to look like half a parabola, and then it's going to be another half a parabola, but going up. So there's a little squiggle line going right through that value. I know that's ugly, I apologize. But that really tells you everything you need to know about multiplicity. The multiplicity of 1 will cross through as a line. The multiplicity of 2 will just touch as a parabola. Multiplicity of 3 will behave like a cubic function. It'll cross through like a little snake-like curve. Okay, now keep this in mind. The multiplicity 2 is just touches, but that goes for any even-powered degree. Most of the time in this class, we're only dealing with the degree 2, or the power of 2. But if you have the multiplicity of 5 or 7, it's still going to cross through as a squiggly line, but in this case, we're only dealing with multiplicity, or most of the time we're only dealing with the multiplicity 3 in this class. So I hope that kind of helps you out, helping you understand multiplicity. Let's get that out of the way. Let's get back to this. So let's talk multiplicity now. What kind of multiplicity do we see right here? That's obviously the power of the multiplicity of 2, because it's a little mini parabola. Of course, it could be 4, it could be 6. We're going with the basics, going with 2. Okay, how about the next answer, which is right here? What kind of multiplicity does the answer x equal negative 2 have? That's the power of 1, okay? So we're going to put a 1 right there. And you don't have to put the 1, but it'll be a little bit less confusing if you do. And now let's look at the final one. The final answer is x equals 2, but of course it's represented with the x minus 2. Remember, the x equals 2 ends up being x minus 2 in factored form. So what multiplicity does this have? Well, that's a cubic function right there. So it's definitely a 3 right there. So ladies and gentlemen, this is your answer, but it's missing one little thing. What is that answer missing? Again, let's mention the end behavior. We know that it's opening down, which means that the a value has to be a negative. So we're going to throw a negative sign right in front of this function. So f of x equals negative parenthesis x plus 4 squared, x plus 2 to the 1, and x minus 2 to the third. That's your answer right there. Now let's move on to describe the end behavior. Okay, so we're going to describe the end behavior, and as x approaches negative infinity, that's saying look to the left. What's happening as you go to the left? Well, this arrow is saying that it's going down forever. So as you're going to the left, your f of x function is going to approach negative infinity also. And how about the next part? It says as x approaches what? Well, you already described going to negative infinity. Now let's talk about going to positive infinity. So let's put that as x approaches positive infinity. You don't even have to put the positive if you don't want to. What does f of x do? F of x approaches negative infinity also, because as you could see, as you go this way, the arrow is pointing down forever. Okay, so we have that. What about minimum, maximum, local min, local max? Well, let's talk local min, local max. When you look at this function, what is the max value? The max value is this guy right here. That's your max value. And I want to label it as the coordinate 0, 3. Okay, that's the max value. Why is it the max value? Because there's no other point on this graph that goes above that value. That's the maximum value right there. Now, if you take a look right here, this is also a max value, but this is not just a regular max value. That's what we call the local max. And the location of that local max would be the coordinate negative 4, 0. Okay, so I hope we understand the difference between your actual max value and your local max value. Okay, your local max is right here. It's not the absolute max because over here there's a higher maximum value. How about the minimum value? If we think about minimum, is there absolute minimum? And the answer is no, because the minimum is actually negative infinity. So you could say there is no minimum, or you could say that the minimum is negative infinity. Now, is there any local mins? Yeah, there's a local min right here. That's a local min, okay? So that is so the local min is negative 3, negative 2. However, it doesn't look like it's really on the 3. But let's just pretend that that dot were a little bit moved over. That way it would be. Because I will do it perfect on the test. I didn't do it perfect right here. I just drew it on the board. Anyways, I hope that clears this up. Just to review further, let's not do the whole thing for this one. Let's just talk about local mins and local maxes for the next one on the class opener. So where is, like if we were to say maximum value, does it have a maximum value? Well, this is a maximum value, this is a maximum value, but I'm talking about absolute maximum. Is this really the highest point in this graph? And the answer is no. Why is this not the highest point? Because over here, you see this arrow? It's going up forever, which is going to be above that point. It goes up forever. So the max value is positive infinity, if you want to say, right? What about the min value? Is there a min value? Well, the min value, same concept. As you go through this, it goes down forever. So you might be thinking, yeah, this is the minimum value. But the truth is the absolute minimum goes down forever. Okay, this is a local min, but this is the absolute min. So the absolute min is negative infinity. Okay, now if you're talking about local max, it actually has two of them. It has this as a local max and also this one as a local max, which would be the location 0, 1 and also 2, 2. And what about local min? Well, the local min would be right here and also right here. Okay, so what are those coordinates? And that would be negative 1.5, negative 1, because if you're going negative 1, here's negative 2, so halfway out, that'd be negative 1.5 and then negative 1. That's the location of this local min, and the other local min is this location, which is the coordinate 1, 0.